Good morning, children. We are proceeding to one of the most interesting concepts, counting. What are the variety of counting techniques we are going to learn in this section? Under counting, we have two important principles called multiplication principle and addition principle. Multiplication, the word and will come to highlight multiplication, and R will come for addition principle. How do I understand it? There are two jobs, let me say A and B. How many jobs? Two jobs. This A job can be done in M ways. This B job can be done in N ways. My question is, go do both the jobs. If I tell you A and B, that is multiplication principle, how many ways can you perform A and B? Tells me M into N. How many ways can you perform A or B? Here I say M plus N. So notice in all the word problems in this chapter as well as in probability, we come across these words and are. So and tells me multiply the two ways. R tells me add the two ways. Either A or B tells me M plus N. Whereas A and B tells me M into N. The next idea, you are given factorial symbol. What do you mean by this word factorial? When I say 0 factorial, you treat it as 1. 1 factorial is also 1. This is by convention. What is 2 factorial? 1 into 2. What is 3 factorial? 1 into 2 into 3. And what is 4 factorial? 1 into 2 into 3 into 4. That is 24. So like this, I can keep on writing factorial. This symbol we call as factorial. 2 factorial, 3 factorial, 4, all these tell me start from 1. Keep on multiplying next numbers till I get that number. If it is 3 factorial, stop with 3. If it is 4 factorial, stop with 4. Now tell me what would be n factorial. N factorial can be written as 1, 2, 3 and so on up to n. Can I rewrite this in any other model? Look at this. 1, 2, 3 can be written as 3 factorial into 4. The same idea for n. The previous number is n minus 1. So I can write it as n minus 1 factorial into n. So most of the problems we use these ideas. N is a general number. The next number means add 1. The previous number, how do you get 3 from 4? 4 minus 1 is 3. So for n, previous number is n minus 1. For n, the next number is n plus 1. Tell me one more. What is the next number for n plus 1? It is n plus 2. What is the previous number for n minus 1? n minus 1 minus 1. That is n minus 2. So we must be able to write with n also. Whenever I need to write the previous number, subtract 1. Whenever I want to write next numbers, add 1. So these are the techniques that we use in this exercise. Exercise 2.2, question number 1. 1 by 6 factorial plus 1 by 7 factorial equals x by 8 factorial. 6 factorial tells me 1, 2, 3, 4, 5, 6. 7 factorial tells me 1, 2, 3, 4, 5, 6, 7. And 8 factorial tells me 1, 2, 3, 4, 5, 6, 7, 8. Factorial is the product of numbers from 1 till that number. 6 means up to 6. 7 tells me up to 7 and 8 tells me up to 8. In all the three terms, 1 to 6 I can cancel. So what remains? 1 plus 1 by 7 equals x by 7 into 8. Cross multiplying by taking LCM. 7 ones are 7 plus 1, x by 7 into 8. 7 and 7 I can cancel. Cross multiplying, x is equal to 7 plus 1 is 8 into 8, that is 64. My question is to find the value of x, and x is equal to 64. Question number 2. Evaluate n factorial by r factorial into n minus r factorial given n is 5 and r is 2. N factorial by r factorial into n minus r factorial equals to n is 5 by r is 2 and n minus r is 5 minus 2, that is 3. So 3 factorial. 5 factorial is 1 into 3 into 2 into 3 into 4 into 5. 2 factorial is 1 into 2. 3 factorial is 1 into 2 into 3. Cancel. So I get 10. 10 is my answer. Question number 3. N plus 2 factorial equals 60 into n minus 1 factorial. What does factorial mean? Start multiplying from 1 up to that number. So what is that number? N plus 2. The right hand side, 60 into 1, 2, 3 up to which number? N minus 1. Now I need to cancel, for which try to write the previous numbers. For 3, what is the previous number? 2. How did we get? 3 minus 1. So for n plus 2, the previous number will be n plus 2 minus 1. What I get? N plus 1. So the previous number is n plus 1. What is the previous number? Again subtract 1. So what I get? N. And what is the previous number? Again subtract 1. So I get n minus 1. So let us remember, whenever I have both the sides some unknown numbers like n, n plus 1, all that, try to write the previous numbers. For 3, the previous number is 2. For 4, the previous number is 3. For n plus 2, the previous number will be whatever number is here, subtract 1, that is n plus 1. Again subtract 1, that is n. Again subtract 1, that is n minus 1. Now 1 to n minus 1, 1 to n minus 1, I can cancel. What is remaining? N, n plus 1, n plus 2. The RHS I have 16. What are these three numbers actually? 3 consecutive numbers. 3 consecutive numbers multiply and I get 60. So try to write 60 as product of 3 consecutive numbers. How will I get it? 60 you divide by 2. I get 30. Again by 2. I get 15. I can put 3 and my answer is 5. So 60 is split into this. I want 3 consecutive. That means next numbers. I have 3 and 5. So the immediate number will be 4. See whether I have 3 numbers from here. 3, 4, 5. So how to write 60? 3 into 4 into 5. This side what I have? N into n plus 1 into n plus 2. Check it properly. N value is 3. 3 plus 1 is 4. 3 plus 2 is 5. So what I get is n equals to 3. Question number 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 6, 7 with no digit appears more than once? My first line suggests it's a 5-digit number. So, see, we put 5 boxes. I need to fill some numbers here. What is the condition? 0 to 9. How many digits are there? 0 to 9. 10 digits are there. And what is the third condition? 67 it must start. So here 6, here 7 fixed. Out of 0 to 9, I am removing 6 and 7. How many digits remaining? Totally there are 10. 6 and 7 I am remaining. So remaining there are 8 digits. So I will say there are 8 digits. And how many boxes are there? 3. Out of the 8, any one will go here. 8 ways. In 8, one number is gone. So now how many numbers remaining? 7. So 7 will go here. Out of 7, one number is gone. So how many remaining? 6. So 6 will go over here. See, totally there were 10. 6 and 7 I remove. So 8 are there. Out of the 8, any one will go here. So there are only 7. Any one will go here. So there are only 6. Any of the 6 will go here. So what is my answer? 8 into 7 into 6. We can explain in words or just put boxes, multiply and write out the answer. We have explained in statement 0 to 9 there are 10 digits. Already used 6 and 7 that are 2 digits. Remaining 10 minus 2, 8 digits. 8 digits in 3 places can be filled by 8 into 7 into 6, that is 336. Question number 5. How many numbers less than 1000 can be formed using the digits 5, 6, 7, 8 and 9 if no digit is repeated? The first line tells me less than 1000. What do you mean by less than 1000? It may have 3-digit number, say 987, 675, like that way it's a 3-digit number, or it may be a 2-digit number like 97, 68, like that way, or it may be a 1-digit number, say 1, 2, 3, they are also less than 1000. So less than 1000 tells me it may be a 3-digit number, it may be a 2-digit number, it may be a single-digit number. What is the possibility for 3-digit number? How many numbers are given? 5, 6, 7, 8, 9. That is 1, 2, 3, 4. 5 digits are given. So we are given 5 digits. And I want to fill up 3 digits. How will I fill? Out of the 5. 1 will go here. Remaining 4. 1 will go here. Remaining 3. So I will say 5 into 4 into 3. The same idea when it is a 2-digit number. 5 digits are given. Any one will go here 5 ways. 1 is gone. Remaining 4. So 4. And when it is 1 digit, the 5, either 5 will be here or 6 or 7 or 8 or 9. So my answer is 5. Add it all. That is my final answer. So 5 into 4 into 3, 16 plus 20 plus 5, and that gives me 85. So this is my given condition and the problem. We are able to form 3 digits, 60 numbers, 2 digits, 20 numbers, 1 digit, 5 numbers, and altogether 85 numbers.